Hey everyone, this is Mayur. Welcome back to MLWorks. In this video, we'll understand what is DPO and how it helps in LLM training optimization. And we'll talk about the previous approaches, which was like RLHF, which was used for LLM training earlier. Okay. So, what is DPO? It is a technique that helps the LLM to generate responses which better match with the human preferences using simple classification approach. And we'll talk about the classification approach in the next set of slides. Okay, let's understand what was the previous approach, right? So previously, when ChatGPT or GPT kind of models were into what built, okay, it was using something called as RLHF, which was reinforcement learning from human feedback. And it is a reward model that gets trained based on human feedback, making it tedious and overwhelming. Okay, that's why DPO came into picture. So there are certain things which DPO does better compared to RLHF. For instance, it totally avoids a reward model since it is complex and unstable, and it optimizes the policy through the preference data. So earlier, the RLHF would create a reward model based on the input given by humans, and it will create a separate model, and that model will be giving the input to the LLM. So now what we do is that directly the LLMs gets fine-tuned on the preference data. Okay. So the efficiency, as said, right, based on the previous 2 points, the efficiency gets improved because we don't have RM model, and also we don't have sampling from language model during optimization. So also we avoid bias mitigation, okay, since we are directly handling the human preference data, okay, for guiding the optimization. Okay, so automatically the priorities of the outcomes preferred by the humans. The model learns the priorities, the outcomes preferred by the humans. Now, what is the difference between DPO and RLHF? Okay, this is the basic difference. Okay, the LLM will produce a couple of answers. Okay, and there will be probability score for each, and it was up to the human, right? They will be choosing which answer is better based on the factors like relevancy or coherence, and also maybe politeness of the answer generated by the LLM. Okay, and it will be passed directly to the LLM. Okay, this is the DPO process. And when it comes to RLHF, we used to generate responses from the LLM, multiple responses, and we'll see the probability score, and we'll be passing to our reward model. Okay, reward model was trained on, right, it is trained on based on the human feedback, and that will be again passed to LLM to get trained or fine-tuned based on these responses. Okay, there is an extra step that is happening because of this. Okay, so we are avoiding that in DPO. So what is RLHF? The whole process of RLHF? Okay, it starts with a base model training, and which will be auto completing the sentences, and the response that is generated by this model, okay, will be sent to the human, and they will rank those responses based on the qualities which I said earlier, which is coherence and relevancy, politeness, and not generating inappropriate answers. Okay, based on that human feedback, a reward model is trained, and that reward model again trains the large language model. Okay, so that is the whole process of RLHF, and this is the objective function what we are seeing here, max of E, which is the expectation, minus of this deviation, which is scale divergence, I guess. Okay, so at E, what is the term, right? It is the maximizing reward term. This is the term that we need to optimize for, and this is like based on the response that we get from LLMs. Okay, this value should be high. Okay, if the response is good, the specific expectation should be good. And the difference between, okay, let me go back to the KL divergence later. Okay, so the model, whatever the response that we generate from LLMs, it should reward higher for the good response. The reward should be less for the poor response. Okay, and the next point is, or the next part of the equation, right, which is minimizing the deviation. So there will be responses, human responses, or some referenced responses, and there are responses generated by the LLM. The difference between these two should be very less, and if it is diverging a lot, then you have to penalize the model. Okay, So that's what's mentioned here in the third point. The model is penalized if the divergence is too high from the reference strategy. Here reference strategy means the referenced response that we expect for a specific prompt. Okay. So while it is learning during this phase, it also ensures that it doesn't generate bizarre results, and we also have to ensure the response that is generated by the LLM, it is like not inappropriate or violating certain content, right? So we have to ensure that, and that's why it's happening. That is what is happening here actually. So the objective is to fine tune the model. Okay, that is not only improves the model. Okay, but also stays within the accepted behavior guidelines. That is the whole part of what RLHF. And the good response that we get, better is the reward, and the poor response we have, then poor, there is like penalization. And these things are taken care by something called as PPO, which is proximal policy optimization, a reinforcement learning approach. Okay, this is the technique that helps the model to learn good response, also ensuring that the response is not inappropriate. Okay. So how DPO works? So the whole part of reward model is removed from DPO, and it uses something called the classification mechanism for like optimizing the LLM. Okay. So what is the first step, right? The LLM, that is the base model, is present, and it will generate the responses. And those responses are again sent to the human feedback. They will check the quality of the response that we got. Okay, based on certain factors called as relevancy, coherence, and politeness or avoidance of inappropriate content. So once that is done, once we get the feedback from the human, okay, we use something called as cross entropy loss. The model then adjusts. So based on this loss function, right, it will effectively increase the likelihood of the preferred response and decrease the likelihood of inappropriate response. So this is the classification loss function, right, which we basically use in many machine learning models or deep learning models. Okay, we use that technique here, and what this will do is it will try to look for labels which are correct labels, and try to avoid labels which are not incorrect labels. It will try to avoid incorrect labels. Okay, that is the major difference between RLHF and DPO, which is the introduction of loss function instead of a reward model. So what does this loss function look like? Okay, so here you have your expectations minus of D, which is again log of sigma beta log of pi theta by pi reference for a given response for a given x, for a response given x again here. So we'll understand each part here. So with respect to theta, it is nothing but the probability score of a preferred response. So here W is the preferred response and L is the less preferred response. Okay. So the probability score of what these response for a given input X, and again here also it refers the same, less probability for what you call less preferred answer for a given input X. Okay. And then comes the part of Y reference, which is again we have reference results or reference response, okay, which is your ground truth. Okay, in a sense it is a ground truth or a baseline. Okay, and the output that you can generate, okay, from your model, it should almost should be similar to what aligned with the referenced response. Okay, and it should not be deviating much from that. Okay, and here pi reference again represents the probability score. Okay, and this is for the probability score for the less preferred response for a given input X. And the whole part, right, the beta log and minus beta log, okay, this represents the optimization. Okay, so this is where you calculate the difference between what the preferred response minus the less preferred response and how much it is deviating. Okay, and beta is the coefficient here, which is the balancing factor that will determine how strongly the model should deviate or adhere to the reference strategy or behavior. Okay, and E, so this is kind of a loss function, right? When you're training a model, okay, if you have remember any basic machine learning model, when you're training it, okay, you will be generating the loss function for a bunch of inputs and outputs, and then you will be updating the parameters. So this is what it happens here. Okay, the whole part E, right? This is what it is. Expected value from the expression is applicable on all possible inputs and outputs. It averages out the adjustment across all scenarios the model encounters to find the optimal overall behavior. This is a kind of a step right towards local minima. You can understand like that. Okay, this is like a step towards local minima. So DPO formula in simple steps. So it helps the model in learning humans' preferred response while keeping the response in reasonable bounds. Okay, it should not provide inappropriate response. Okay, and it should follow something with respect to the reference policy. Instead of reward model, it directly uses the cross entropy clause to evaluate the response while adjusting the probability score based on positive and negative response. Okay, so this is quite simple. Okay, the core innovation lies in the reparameterization of loss function used in RLHF, and manipulates the model strategy by simple classification laws, thus making DPO robust. So this is the basic idea, right? You are introducing a loss function, and that loss function learns based on the human feedback, okay, and tries to optimize or fine-tune the large language model. So what has happened, right? Once this is done, okay, what is the performance or evaluation strategy? So what it was seen is like DPO achieved a winning rate of around 61% at a temperature setting of 0.0, slightly higher than PPO, which is the proximal policy which we saw earlier. Okay, notably DPO maintained consistent performance across various temperatures, showcasing greater stability across two PPO, which experienced more variability in its result. So overall, the performance, right, the response that is generated by the LLM, okay, has improved using this approach, and even across different temperature in a sense, this is a parameter that we set in large language model to making sure how the model responses, right, like how creative the response can be generated by the LLM. Okay, that is the setting for temperature. Okay, so DPO achieves across different temperature settings. It is performing well and it is consistent. Okay, and compared against PPO. So we are almost at the end of the video. Okay, these are the references that I have used. So let's see in the next video. Thank you for watching.